I thought you were going to say from the other side. That's okay. All right. Let's try this one first. Guys, just get your brain ready. This one's going to be a lot tougher. Okay, is everybody ready? Mentally ready? Physically ready? Facing forward? Yes, physically ready. Thank you so much. Thank you. This is a lot. Okay? All right. So we got the same thing, Anita, you asked about the -9 to 9 on the last link. So they're telling us again to focus on -9 to 9. To help you out when you do this on your own, obviously I can't move this, right? But you will be able to move this around. All right, so if that helps you, you can do it. We try to do it visually as well, but this will give you the exact value of those slopes of the tangent lines. So there's two things we got to do. The first thing we got to do is find where the derivative of our values evaluated are positive, so greater than or equal to 0. All right? Now, I always tell students this. I know you're going to be like, Mr. Vendrick, it says it. They're going to try to mess you up on the AP exam. Always look at what they're labeling this graph. What is this graph? The original function. So just be aware, they're going to sometimes give you the derivative. So just be careful. Always check, what am I looking at? Am I looking at the original or something different? Okay? So if I'm looking at the original, how do I find where the derivative values would be positive? What am I looking for if I have the original function? How do I do this? Julia? You said something? What's going up? Interesting. So you're saying I should look where, first off, we don't want to say line, right? What is this? No. You're thinking too hard. It's a curve, right? No lines here, right? It's a curve. All right. So you're saying look where the curve is. I don't want to say going up. What word do we use in math? Increasing. You could also do what you just did, right? Find your slopes of your tangent lines. Okay? So if I look at this first one here, I don't know why I keep hitting highlighter, guys. I'm so sorry. There we go. Is that positive? Is that pink line I just drew a positive? No. So am I going to be counting anything there? No. But after I get past -7, what's happening? Those are positive. So in terms of f prime of x greater than or equal to 0, I'm going to start with -7. And let's see, and we can do Georgie's thought as well. All right. These are all positive still. Where do I stop having positive tangent lines? Or, because Georgie had a great idea, where does it stop increasing? Where does the function stop increasing? At -5. Excellent. Write it down. Okay, now this symbol we used yesterday, if you have more than one interval, you want to use the union symbol. All right. Where do I pick it back up? So let's look at Georgie's idea where it's increasing. Am I increasing here? No, decreasing. Then I'm going to start increasing at -1. Right? Those are positive slopes. Right? Those are positive tangent lines for the slopes. Where do I stop increasing? At +3. Say one more time. I don't know. Let's see. Am I increasing anywhere else? Yeah, right here. So another one. And then what's my last interval going to be? 5 to 9. No infinity, right, David? Because we're only going -9 to 9. Edwin, you good? Okay, excellent. Any questions on the first one? No. We're getting there, okay? Remember, when I put these here, I try to do what I think are the hardest ones first, okay? Here's the next piece. It says, where is the original function, so f of x, greater than or equal to 0, or positive? So now I'm looking at a different one. Where is all of my y values positive or greater than 0? Let's start at the beginning. Would this have a positive y value?
No.
Yes, right? Because we're just looking above what? Above the x-axis, right? So am I above the x-axis? Yeah, what about here? What do I do here? Why does it count? No, I'm not above. What symbol tells me it counts? Or equal to. This symbol here tells me it counts, right? That tells me it counts. All right? So I'm still good, right? Still good? When am I not good? When I get past 4, all the way until 8. So here's how I write it. I'm going to write -9. You said till 4. And then I do have a tiny little bit at the end where I'm still okay, where I'm positive. I should say the function is positive. So it'd be 8 to 9. Since someone's probably thinking it, you can always use parentheses when you're doing this process. See that work there? Always parentheses are fine. All right? And then use the use if you've got more than one.
But in Dutch, we have to use parentheses?
No, you can use brackets. I tell students you won't get into trouble if you use parentheses. If you start using brackets, then there are times that's not appropriate. All right, so I would recommend.
You have to use it. Like you can't not just.
You're right. You have to use something. You can't just put the numbers. Good question. Yeah.
If the function was in that 8, would it be just -9?
If the function, say it again. If it did come back,
Yeah.
so if it just stayed down here, yeah, I would be done after the 4. Yeah, good question. Okay, now we're not done. This is what I think is the hardest part. Go ahead, David. Sure, absolutely. You want me to zoom in on the graph?
No, it's fine.
Okay.
What if it goes like this, and then it just goes like this?
So like back down.
Ooh, good question.
Because it would cross at 0 at one point, and then it'll just go back down.
I'll tell you this, for this particular like delta math, they're not going to do anything like that. But technically, because it does say or equal to, you would have to count that if it does touch it again.
Wait, so number 7 doesn't count? I mean -7?
No, it's okay, right? We said this is fine because it is equal to. Right?
Oh, so
Yeah.
you're saying, right, so you're saying don't.
He's saying if it like came back and didn't cross, like if I like stayed here, would I have to count 8 to 9? Technically, yes. That's what I think he's asking, right? Yeah.
What? I'm
Don't worry, you're like doing some amazing thinking, which is going to help you in life. But on this, you don't need to. All right. But I love it. I love your head tap. You're good. I promise. Okay. Here's, I think, the hardest part. Okay. What word is in between them? And. So you can't just like list them all and say, I'm done. You have to think about which of these intervals or pieces of the intervals are going to work for both, which is the most challenging part, at least for me, I think. So what I did first is I am going to use my marker here to show you -9 to 4. All right, you ready? So here's -9, and here's 4. That is where the function, at least in our first interval, is positive or greater than or equal to 0. Okay? So within that interval, do you see, guys, the green kind of vertical lines? Within those vertical lines, where is the derivative going to also be positive? Does -7 to -5 work? Is it in there? Yes, it does. What about -1 to 3? Does that work? Is that in between there? It is. So when I write down my answers, I'm going to write down those two to start. Everyone still good? Okay. Now there was a second interval. The second interval where the original function is positive is 8 to 9, and it's a little smaller, so I'll show you here. I'll erase David's thinking. Sorry, David. So here's 8, and here's 9. Okay? So within that interval, do I have 5 to 9? No, I don't, right? Because the 5, 6, 7, all the way to 8, I don't actually have a positive value there, right? My original function is negative. So what am I going to put for my last interval that's going to work for both? Can I put 5 to 9? No. What can I put? Nice, Gael. I can put 8 to 9. I can put a piece of it because some of it is going to hit both of those things, where the derivative is positive as well as the original. I think that is the toughest part. So when you're getting these questions, if you have any issues on that, we can talk about it, and we'll talk through it. Any questions on the first one? Okay, let me do one more, and then I'll give you guys 10 minutes because we get out at 29. So let's do one more. I'll give you 10 minutes to practice. Okay? All right, let's go to the next one. All right. Next one says, same -9 to 9. We're looking, where does f prime of x go from positive to negative? All right, so again, what graph are they giving us? The original function, right? This is the original. So I have to actually do one of two things. You could do the way that I just taught you on the previous link, which is find the slopes of tangent lines. All right, so let's talk about the first one here. Let's see if I don't hit highlighter. Yay. Okay. So start at the beginning. Are these slopes going to be positive? No, right? Those are negative slopes. I'm looking for positive to negative. All right? So in terms of this slope, is that a positive or negative? That's a positive. Okay. So we're getting there. We're finally going from positive to negative up at this point right here. You guys see that point? That's where we're switching. And I heard Bernadette say it. What's the x value? -2. Now, can anyone say one of the math or calculus vocab words about what is happening at this point right here? How would you describe that point?
Relative maxima.
What up, Bernadette? Do you guys see how that's a local or relative maxima? Because we're going from increasing to decreasing. So now you can, at this point, what I'm telling you is stop doing that. And when you get a problem like this, where it says positive and negative, I'm just looking for all relative maxima. So what if it had said where it's going from negative to positive? Then I'm looking for all relative minima. So you can also, your brain's, I'm not expecting you to get this right away, guys, but that's my hope over this week, that you start to see different ways to do these. And I think that's a little easier. All right, so where is another relative maxima? It's 7, well done. All right, this point right here. So you would type in those two. Now this is where Jimena asked about the parentheses. I would not use parentheses here. The delta math, you just type in -2, and then I think you hit comma, right? Hit comma and adds, or it says can you add another solution?
Yes.
Just click that button and you can type in 7. Okay? Is everybody good? All right. We're all good on stopping now to try some, right? Even though I'm skipping a couple? Yes, we're good? Okay. I'm going to stop now and give you guys